Hello and welcome to video number 16. My name is Atayb Abul Yaman. This video honors a request by one of our subscribers to give a layman definition of a function. So what we will be doing is, first of all, we'll be giving a calculus-oriented definition of a function, and then we'll talk about the layman definition of a function, and then after that we will go ahead and break down the calculus definition of a function into characteristics that we will use to identify what is a function and what is not a function. And that's basically what we'll be doing here. So let's get going and list the definition. From the calculus point of view, if the value of a variable y depends on the value of a variable x, then y is a function of x, denoted by y equal to f of x. If and only if every x in the domain of the function f is related or mapped by the function to a unique y in f's range. That is a little bit too much as a definition, but it encapsulates all the characteristics of a function. And for that reason, we're going to go ahead and break all the characteristics so that we can identify a function. A function is the one that satisfies all the characteristics or the conditions. In a layman term, we can talk about a function, for example, as earning sustenance in life is a function of effort. If there is no effort, no earning. And earning is usually directly proportional to the effort. We could also say that the speed of a vehicle, for example, is a function of acceleration. The more acceleration it is, there is increase in the speed. We could also say the buying power of a person is a function of dollars. How many dollars a person have will determine the person's buying power. Now let's get back to our definition, and we'll go ahead and list the characteristics of the definition. So the first characteristic of a function is that it has a domain and a range, and we will identify them in a minute. Second is it's a relationship between two variables. As we said here, y equal to f of x, so it relates y and x, where x is the independent variable and y is the variable that depends on x. Any changes in x will change y. Here is the relationship. The relationship in calculus is like y equal to f of x. Condition number 3, a function maps every element of its domain to an element of its range. Here is an example. Let's take a look at the 3 conditions so far, and let's see if the 3 conditions are met by this model. Has a domain and range. The domain is where the arrows start, and the range is where the arrows end. And the arrows map elements of the domain to elements of the range. So it has domain and range, a relationship between two variables, because these values of the first variable in the domain, and these are values of the second variable in the range. So the first variable is the independent variable and the second variable is the dependent variable. It maps every element of its domain to an element of its range. It says it maps every element of its domain. Let's take a look at the domain of this model. The domain has 1, 2, and 3, but this model maps only 1 and 3. It doesn't map 2, so it violates this condition. So this is not a model for a function. Let's check another model. In this model, we have 1, 2, and 3. All of them are mapped to a unique element. And by unique element, we mean 2 is mapped only to A, and 1 is mapped only to C, and 3 is mapped only to C also. So as long as none of these elements in the domain is mapped to more than one element in the range, then we can say that every element in the domain is mapped to an element in the range. So maps every element of its domain to an element of its range. These three conditions are satisfied by this. But these are not the only conditions. So far, we'll say, so far the blue satisfies all the three conditions and red failed the last condition because not every element of the red in the domain is mapped to an element in the range. So this is not a function. We're not going to go ahead and examine it. We'll continue examining this one as we add conditions. So let's take a look at this. Is just the general abstraction of a function. That means the function operates on the domain and the arrow points to the element in the range that's mapped to by the element in the domain. So let's go ahead and look at condition number 4. Condition number 4 states that the mapping may relate multiple domain elements to a single range element. The mapping may relate multiple domain elements to a single range element. So here are multiple domain elements, 1 and 3. 1 and 3 are mapped to C. So this is satisfied here. So it's possible that we map more than one element of the domain to the same element in the range. As a matter of fact, we can map all the elements of the domain to a single element of the range, and it's still a function. So this condition is satisfied so far. Is there any other condition? Let's take a look at this model and let's see if this model passes these conditions. No question, it has domain and range. No question, a relationship between two variables because there is a variable that's represented by its values in the domain, and there is a variable that represents by the values in the range. So that's met. Maps every element of its domain to an element in the range. Yes, indeed, every element is in the domain is mapped by at least one arrow to an element in the range. So this condition is also satisfied. Let's take a look at this condition. The mapping may relate multiple domain elements to a single range element. It may map multiple domain elements to a single range element. And sure enough, we have 1 and 3. 1 and 3 are mapped to C, which is okay. 1 and 3 are mapped to C. So far, condition number 1 is satisfied. Condition number 2, relationship satisfied. It maps every element of its domain to an element of its range. So every element of the domain is mapped to an element in the range. Here we can see that 2 is not mapped to an element, but 2 is mapped to more than one element in the range. 2 is mapped to more than one element in the range. So this is not a function. So let's put that condition now. So we said the mapping cannot relate multiple range elements to a single domain element. And here are multiple range elements, which are A and B. They are mapped to by a single domain element, which is the 2. And that is in violation. That's indeed in violation. And we could just think about this as, for example, students. This is student number 1, student number 2, student number 3. And these are their grades. So we cannot have student number 2 obtaining an A in the course and he's also obtaining a B in the same course. So mapping the students to their grades is a function. But here, this cannot be mapping of grades because student number 2 cannot have a grade in the same subject as A and also has B for the same subject. It cannot be. So this is not a function. We will go ahead and demonstrate the function also using the vertical line test. The vertical line test, let's take a look at the 2. The violation is 2 is mapped to more than one element, 2 elements. So if we plot in the y axis, where x is the independent variable and y is the dependent variable, we plot 2 here. So x is equal to 2. What is the value of y for x? We will look here. The value of 1 for x is c, but we're not plotting it. The value of 3 for x is also c. We're not plotting it. Let's take a look just at 2. So 2 has an f value equal to a and an f value equal to b. So here is a 2. It has an f value a and f value b. So a must be 2 units away from the y-axis and b must be 2 units away from the y-axis, and that's why they are in the same line with 2, a and b. And this is what is known in calculus as the vertical line test. Vertical line test will show you whether something is a function or not, one of the conditions. So we can see that this model violates this condition. And the simple question that anybody could ask is, what is f of 2? This is 2. F of 2. Should I go up and say it's equal to a? Or should I go down and say it's equal to b? So this is not a function. Let's go ahead and take a look at a review question. And for the review question, we assume that we have 3 students, student 1, 2, and 3. And the students, they earn grade upon completing all the requirements for a course. So let's take a look at the question here. What we have to do here is to match the following grade relationship to the diagrams. So let's take a look at the grade relationships and the diagrams. And obviously we have to also justify our answers in each case. So let's take a look at the relationships. We have 1, 2, 3 relationships. We have to map them to 1, 2, 3 models. If we look in the first one, it says it is a function and a grading system at the same time. Let's check, starting with the black model. It is a function. We said if it is a function, it has to avoid 2 things. No single element from the domain should be mapped to more than element in the range. And we can see that 2 is a single element in the domain and it's mapped to 2 elements in the range. So this is not corresponding to this because this is a violation. So this cannot be a function because it violates what? It violates the vertical line test because 2 has a value a and b. It also violates the grading system because student 2 cannot have an A and a B in the same course. So this is not matching that. Let's take a look at matching the first relationship with the second model. The second model, 1, 2, 3, all covered, all mapped, and none of the domain element is mapped to more than 1 range element. So this is indeed a function. So at least we identify this one as a function. So now we have mapped this as a function. Let's move to the second one. It is not a function because of the domain. That means a problem in the domain. Let's check the black one. The black one, it's not a function. Is it because of the domain? The condition for the domain is that every element in the domain must be mapped. And we have every element of the domain is mapped. So this is not the condition that we're looking for. The condition that we're looking for is, let's try here. Okay, it is not a function because of the domain. Here it's the condition for the domain is violated because the condition for the domain says every element in the domain must be mapped to an element in the range, and this is not the case with this one. That means we could also say that 2 is mapping the brown model. And let's take a look at if the last relationship maps to the black one. It says it's not a function because of the range. What is the violation of the range? We said there should not be two elements in the range that are mapped to by an element in the domain. And we can see 2 in the domain is mapping to more than one element in the range, and that's the violation. So that could be also corresponding to this. Now that we've gone through this one, our next video will be about the functions, whether or not they are even or odd, whether or not the functions are linear or non-linear, and so on. Thank you for watching this video, and we hope you enjoyed it. And we also request that you subscribe, because we're going to have lots of questions that we will be answering, and at the same time also we give some of the questions that may be looked upon as research questions. You have a good one and stay healthy.